Alright, so related rates. Maybe I'll just start with an example and then I'll give you kind of the sequence of how to solve these problems along the way. Let's say we've got a 17-foot ladder leaning up against a building. At this point we'll say it's 8 feet away. Here's my building. And the end of the ladder, so the ladder starts to fall down the building. This is my ladder. So let's say the end of this ladder right here starts to fall down at we'll say 2 feet per second. So if that's the case, how fast is this end of the ladder going away from the building, so sliding outward? So we're trying to find out how fast this is sliding out, knowing that this is sliding down when it's 8 feet away. Alright, so we need to set up some variables. So I'll call this one X. That is a variable because it's 8 feet right now, but it's going to be 9 feet and then 10 feet, so it does change. So that is X. It's a variable. This is also a variable. I'll call it Y because this distance from the ground up to the top of the ladder is changing, so that's a variable. This hypotenuse does not change because it's always 17 feet. The ladder doesn't change the distance. So we don't have to assign a variable for that. So what are we given? We're given how fast this is going down, so that is dy dt. So we know dy dt, the rate in which y is changing, is 2, but y is getting smaller. Since y is getting smaller, it would be negative. So it's not because it's going down necessarily. It's because y is getting smaller. So if it's getting smaller, it's negative. It's getting bigger, it would have a positive rate of change. So negative 2 feet per second is given to us, and we are looking for dx dt equals question mark. So how fast is this moving out away from the building? Alright, so step 1 is to, we'll do steps along the way. Step 1 is to make a sketch and label variables and such. And make sure you write down givens and what you're solving for. So all that could be one step, but I ran out of room, so I made it 2 steps. Okay, so make a sketch, label the variables, write down what you know and what you're looking for. So that's what we have done so far. Hey, we're 2 steps into it already. Okay, so number 3 is to write an equation to relate the variables. So how are x and y related? Well, sometimes it's going to be geometric shapes, sometimes it's going to be, well, a lot of times it's geometric shapes. In this case, we have a triangle. So we know that using this triangle right there, Pythagorean theorem says that x squared plus y squared equals 17 squared. So that's my equation. In this problem, my equation is x squared plus y squared equals 17 squared. And that's a lot of the times the most difficult part, to kind of figure out what the equation is. Okay, once you have the equation, we always differentiate with respect to time. So find derivative time. So d dt. Find the derivative with respect to time. Okay, so we can do that. The derivative of x squared is 2x dx dt plus the derivative of y squared is 2y. I'm going to pause here. Continue. So find the derivative with respect to time. We did that. The derivative of x squared is 2x dx dt. The derivative of y squared is 2y dy dt equals the derivative of 289 is 0. So the derivative of constant is 0. So we're using implicit differentiation because all of our variables here are not time. So you always have to attach a dx dt, kind of like we did when we were doing x's and y's. We'd have to attach a y prime or dy dx afterwards. Okay, so once we have our derivative, we're going to plug in. Actually, yeah, so plug in and solve. So we know x is 8. The most common mistake people do is they plug 8 in for x right there because, well, we know that x is 8, so we plug it in. You can't plug it in until after you do the derivative. So once you do the derivative, then we start to substitute things in. So my x is 8. Dx dt is what we're looking for. My y, well, we don't know it, but we can solve it using the Pythagorean theorem. So 8 squared plus y squared equals 17 squared. Carry the 1, y is 15. So 15 dy dt is -2, and we can solve for dx dt. Now the rest is just algebra, so plug in and solve. 16 dx dt minus 60 equals 0. 16 dx dt equals 60, so dx dt equals 30 over 8, 15 over 4. We'll call it 15 over 4. Okay, so the last thing, right, so answer question with the units. So, and check the sign. See if the sign makes sense. So sign meaning plus or minus. Okay, so dx dt is 15/4. Does it make sense that we got a positive answer? Well, dx dt, even though it's going to the left, x is getting bigger, so we have to have a positive answer. So we did get a positive answer, so we're feeling pretty good about that. If you got the wrong sign here, then you probably assigned the wrong given, like we plugged in 2 instead of -2 for whatever was given. So check the sign and then write out the answer. The answer is 15/4. Make sure you include units. It would be feet per second. Dx dt. All right. Questions on that? My dog has it. All right. A follow-up question we could ask, as long as we have this scenario already created, we could ask another question, maybe a couple different questions. I'll start with one. Let's say, how fast is the area changing? Okay, so how fast is the area of the triangle changing? If we look at the triangle as it is, do you think that the area is going to increase or decrease at this point? This turns out to be 15. Any thoughts? I guess this is not an interactive presentation. Alright, so if I drew this to scale, so that's not really drawn to scale. If I drew it to scale, it would look kind of like this. And if this ladder is sliding down, it's going to look like this. Is this triangle going to be larger, have a larger area than the original one? What do we think? Larger area or smaller area? Alright, I will...
Smaller?
Okay,
Larger.
we have both covered. Okay, so thanks for the participation. Well, what if I asked you what kind of, if this is 17, what's the maximum area? What would it look like if the hypotenuse was 17? What kind of a triangle would produce the maximum area? Anybody know? A 45, 45, 90. So if it's this one, it's going to produce the largest area possible. Right now, this side here is larger than this side. For a maximum area, these two sides would be the same. So since it's sliding down, this side's getting bigger and this side's getting smaller, the area should be increasing until it gets here. And then after that, if it keeps to sliding down, then it's going to start to get smaller and smaller. So for our purposes, our area should be getting larger. That was a lot of questions just about one little part of the problem. Sorry about that. So we have to create, we've got our sketch. We're looking for what givens and what we're solving for. We've got everything labeled except for what we're looking for. In this case, we're looking for dAdt. So dAdt is our unknown. We can find the area. The area equation is 1/2 base times height. In this case, it's 1/2 x times y. So remember, we don't know x and y. X and y are always changing. We know it at exactly one point, but they do always change. So those are variables. So it's 1/2 base times height is the equation that we'll use for our area. So now we can find the derivative with respect to time. That's dAdt. How fast is area changing with respect to time? Equals, we'll do a product rule. I'll float the 1/2. So x dy dt plus y dx dt. dAdt is what we're looking for. My x we know is 8. dy dt, that's given to us. That was -2. My y is 15. That's 15 over 4. So we have everything that we need. We just now have to do the algebra and figure, it's not even algebra, it's arithmetic. And that'll give us our answer. So all right. So 0.5 times -16 plus 225 over 4 gives us 20.125. So dAdt was 20.125, and we talked about the fact that it has to be getting, it should be positive because the area is getting bigger. Now the units would be feet squared per second.